we're going to look at scientific notation. Now, scientific notation falls under this whole exponent category because we're moving our problems using exponents. We're going to be doing exponent operations. So some of that stuff that we've learned before is going to come back into play here. But before we do that, let's understand what scientific notation is. Scientific notation is a way to write a really large number in a really large or a really small number in a more compact, easier to read way. And then you're going to see this form, this term, standard form. We use it a lot in math, but specifically with standard form, it just means a number. Same old number that you've been dealing with your whole life, just a number. And then scientific notation, what is that? Well, the specific way of writing it's always going to be a number times 10 to an exponent power. That number in the front has to be between 1 and 10. It's allowed to be 1. It's got to be smaller than 10. So things to keep in mind here. Before we do any of these confusing looking things, let's just rewrite our problems. So standard form to scientific notation. Currently, my decimal's right there. I want it to go between 2 and 0. So we rewrite 2.01. Now we don't want to put those extra zeros there. Anything after that decimal is kind of extra noise. Just get rid of it, forget about them. Times 10. Now we got to figure out how many times we just moved. We were originally here, we went 1, 2, 3, 4, 5. I put those little waves under there just to kind of count how many times we go back and forth. Let's do the same thing with the other one. Now we have a decimal, a small number. I want my new decimal to go between 5 and 1. So I rewrite that, 5.1 times 10. Now how many times are we moving? 1, 2, 3 times. Okay, now there's one little problem that I made. There's one little mistake I made here. One of those has to be negative. Now, I like to remember that. I'm sure there's rules that say go left, go right, do this, do that. I don't know. It never stuck in my head. I always like to know that this is a really large number. I get a large positive exponent. This is a really small number. I'm getting a really small negative exponent. So when you're starting off with a decimal of something, something less than 1, you get that negative exponent. So standard form, scientific notation. Now let's go in the reverse. If I'm given scientific notation, I want to rewrite it in standard form. So I need to move my decimal 4 times. Now that's a positive that says I need to get a larger number. So I'm going to take my decimal and move it 1, 2, 3, 4. And I'm kind of putting these like little phantom waves under here to count my zeros that don't exist yet. 6, 3, and we're going to have 1, 2, 3 zeros. There's your standard form. Let's look at the next one. We've got 4 times 10 to a negative 2. That negative 2 says I'm going to get a really small number. I'm going to get a small decimal. First off, right now my decimal is behind that 4. I need to move it 2 spots smaller. 1, 2. I'm left with 0, 4 with a decimal all the way out in front. And mathematically correct, you can put that 0 there. Okay, now what does that have to do with evaluating? Well, a lot of times you're going to be asked, write your answer in both scientific notation and standard form. That's what we're going to do right here. But we're also going to follow some of the rules that we do with exponents. So when it comes to multiplying, if there's multiplying all over the place, where between the questions there's multiplication, with the exponent there's multiplication, and this multiplication symbol that we don't normally use anymore means multiplication. We only use it with scientific notation. Because there's multiplication everywhere, we can go out of order. I want to multiply 3 and 4 together. That gives us 12. I then want to multiply my 10s together. Now remember, we're doing 10 squared times 10 to the third. Isn't that just like doing x squared times x to the third? And when you have that, all you have to do is add your exponents. Here, we're adding our exponents. 2 and 3 gives me 5. We're going to call it a day. Except that's not scientific notation. It's close, it looks like it, but that's 12. It's got to be between 1 and 10 cannot be 10. So how do we get out of this? I want to rewrite my problem in scientific and standard form. I like doing standard form first. Exponent 5 says, let's go larger. 1, 2, and we want to go 1, 2, 3, 4, 5. Add your zeros. Add your commas. There you go. 1,200,000. Now we need to write that in scientific notation. We now want our decimal to be between 1 and 2. And originally it's back here. We're going to go 1, 2, 3, 4, 5, 6 spots. That's what we're looking for. Scientific and standard form. All right, let's do it with division now. So when it comes to division, same process. 2 divided by 4 is going to give us a half. Now, can we give that as a decimal? It's going to be 0.5. Now, when we had our exponents next to each other, we added. When you have exponents up and down, we need to subtract. 3 minus 5 is going to give us -2. I need to rewrite this in scientific notation and standard form. This is not scientific notation because that is not between 1 and 10. So let's rewrite it in standard form first. Negative exponent says let's get smaller. 1, 2. So we're going to have 0.005. Now I want to rewrite this in scientific notation. I want my decimal to be here after that 5. So I want it to say 5.0. We don't need that 0. So just 5 times 10, and we're moving it 1, 2, 3 spots, but it's a negative number or a small number, so we get a negative exponent. There is standard and scientific notation. And let's do one more. This time we're going to be dealing with a lot of negatives here. So 9 divided by 3, 3 times 10 to the power. So we have to do a little bit of work here. We need to subtract these, but there's negatives all over the place. So what we're going to do is say -1 minus -5, because remember, subtract the two numbers. Negative is a positive. 5 minus 1 gives me a 4. My exponent's 4 now. Is this in scientific notation? This number, between 1 and 10, we like that. We're halfway done. We just need the standard form. Move this decimal 4 times to make it bigger. 1, 2, 3, 4. Fill in the holes. And we're left with 30,000. And that is scientific notation problems.